Live, maybe. Let's check. Let's check to ensure that we are live, maybe. So, go to YouTube. I bet you, or let's look at Restream. Oh, I have not done any of my regular Restream because I don't have my chat up. Restream. Oh, already even account login. Oh, this is a nightmare. You're supposed to be here. Good thing I don't get any viewers, right, team? So, oh yeah, my Twitch is down. My LinkedIn is down. But my YouTube appears to be successfully live, which is the one that really, really matters. So that's good. Let's open chat to see who's complaining about me not being here. Chat. Open in browser. And here we go. Now we have a chat with nobody watching. Good. Well, I mean, relatively good. It's good that I'm not wasting anybody's time live. But it is rubbish that I have. Okay, here we go. So we are on week 10 of 14 in the presentation of. Oh, and somebody is here. I wonder if that's actually just me watching myself. But hello if you are a real person, and if not, let me test this. Test. Ta-da. Here we go. Okay. So we are in week 10. Oh my gosh. Can you believe how far we have come? I think it was really fun. Really fun. About a week ago, maybe it was last week, maybe it was the week before. So we're doing at, here, let me show it. At Zensurance. Zensurance. At Zensurance, we are also doing the Clean Architecture Book Club. And one of the members of the team came out and just echoed almost exactly what I'm thinking about this whole thing too, which is we may as well call this book Use Interfaces, right? Like, I'm just going to adjust this. My head's a little... There, how's that? A bit better, a bit more arms. Okay, there we go. So we may as well just call the book Use Interfaces because that's sort of the number one lesson that we're really pulling out of it. I mean, anyways, I thought that was pretty cool. So last week, let's sort of recap what we talked about last week. We talked about policy and level, where just a philosophical discussion about what makes a software system to be. Oh, you know what? I do not have my notes up here on stream, so you're not looking along. So I'm going to scroll through these with you. So last week we looked at policy and level, we looked at business rules, and we looked at this thing called screaming architecture. Look at that handsome fella. You should open your eyes on camera, buddy. So business rules and stuff. I think we're okay on that. And the point of screaming architecture was that we should be able to look at the code for something that we get, and the thing that the system does when we look at the code should just leap off of the page at us. So that took a little while to come around. So this week we talk about the author's take on what clean architecture finally actually is at its very core. And I see somebody else has showed up. Hello, thank you for joining. We are on week 10. We are talking about clean architectures and this thing called presenters and humble objects, which once we've talked about what clean architecture is in general, we're going to move on to, let me bring up my Mike Stewart. What? How are you doing, fella? Are you still at you joined Sensei for a while, didn't you? Anyways, ahoy. So I'll keep going, and then if I see a chat back, I'll read it out and say hello some more. So, one of the things that the author does is that for you're setting up a new OnlyFans or something, something for dirty architecture. Um, the book talks about hexagonal. Well, he talks about a number of books around the concept of architecture where we have multiple sorts of people have come out and written their takes on architecture, and the author of Clean Architecture sort of read all of those books and formulated a list of all of the things that they came out with that make them or what are their commonalities. And so the book Growing Object Oriented Software Guided by Tests is this one was the hexagonal architecture description. The DCI is data context and interaction, which is another architecture description, and this one comes up more than once. There was some really interesting there was one thing that I saw a summary about DCI that said it was like the most significant thing to happen to Java since, I don't know, sliced bread or whatever. People make bold claims. Object-oriented software engineering, a use case approach from. Hey, John! Hey, good to see you. Glad you came around. And look, I am streaming to Twitch, even though they have reset my stream keys. That's cool. Good. Nice to see you. You should meet Mike Stewart. He's watching via Facebook right now, and he and I worked together at Click, and he's been programming probably. Well, how long have you been programming now, Mike? 25, 20 years? Somewhere in there as well? John Kugelman here is also a 20-year programmer, so we're all very, very long-lived in our careers so far. John are you still in the defense industry, John, or are you, you actually can't tell us what you do now, I think, if I remember correctly. It was previously defense, and now it's top secret. You do stuff with computers, maybe. Yep, still defense. Can't actually tell us the details. And but a lot of Java stuff, a lot of security, like doing security for the Navy, like just the coolest. Mike, you should probably about 18 years for Mike. But yeah, you could actually go on the channel, on the YouTube channel, which I will bring up here in another tab first. So on the YouTube channel, we actually have an interview with John where we get to know him, and he tells us all about his career. So right here, you can talk to Kugelman. Yeah, 18 years. What a youngster. And also, John, you might not have seen this one yet, but it's a brand new interview with a fellow named Peter Stout. He is a Netflix engineer. He's been at Netflix for about 11 years. He started out working. He got his PhD at Carnegie Mellon. He wrote his first program on punch cards in high school in Fortran. What are some of the other highlights? He was at Google, and he was at this place called General Magic, which there's apparently a documentary that you can watch about General Magic where in about 1995 they have patent diagrams of what is effectively the iPhone. And, so they were 10 years ahead of their time on the iPhone. And then apparently they also had this section of stuff that they did where at General Magic, they were inventing voice communication systems like Alexa in, again, like 1995, 1998, like just decades and decades ahead of their time. So that's and he wrote the global shaping algorithm that they use at Netflix and things. So this one would be new to you, I think. And for Mike, you could also watch John's interview where he tells us the story of his how he came up through the defense industry and how he spent 18 was it you were I think 14 or 18 years at the same company, and sort of we walked through how your career evolved while staying at a single employer. Anyways, all things all things aside, I bet you two guys would get along if you took a moment to chat. So it was it was a fun chat. I liked it. It was good. So no, they were really no, they are really enjoyable. So back to the story of today. So that's fair. That's fair. Um, so the story of the day is sort of Uncle Bob, Rob Martin, the author, goes through and he says, these are the multiple architecture types that we have, and they all have these commonalities between them, where the architecture is independent of the framework that you choose. It doesn't matter if effectively it doesn't matter what language you use. It matters how you structure the things that you're working with. It matters that they're testable. It matters that we have unit tests. I think, and writing unit tests makes you write your code differently. It's really really important to do that. I mean, unless you work in the agency world, I think. So, which is a bit facetious. We should have been doing that for 10 years at the old place. But so independent of the UI, we've talked about this in previous weeks, where the business rules should be sitting in their own logic off to the side that is written in a way that's highly testable, whereas the front end should be as deeply decoupled from the central business rules stuff and the calculations. Actually, I think, Mike, you were probably the first person to explain to me what a view model was, so it's actually a real funny coincidence that you showed up today, because the view model connection is how we get sort of dumb objects out onto the front end to... Anyways, we'll talk about that in a second. So independent of the database, so again, around the idea that we want the system to be testable. If we want them to be testable, we want the tests to be fast. And in terms of the speed of tests, as soon as we are going through over the wire and we're doing database reads, we're hitting the disk, all of that slows stuff down incredibly. And so we want to write things that are independent of, in fact, any external agency. So all of our things should be tightly coupled. And there is a diagram where they are... Our systems are sort of like, I don't know, rings in a tree or layers in an onion. And in previous weeks, we talked about directed acyclic graphs, where we want to make sure that every component in our system is not dependent on any other component, except to the extent that it is unidirectional. So we don't want circular dependencies. We want to, when we have to, we would write an interface to make sure that our connections between systems and components are as firmly and deeply decoupled as they possibly can be. And this diagram sort of explains the hierarchy or the importance of the various systems. So each ring that goes further and further in to the center should have no knowledge of the systems outside of it. So on your entities layer, you would remember from a previous week that entities are the combination of data and business rules in the same place. So on that deepest level, they would have no mention of any other variable names outside of themselves. So they would be completely standalone. They would have zero dependencies, and that would protect the core business rules from all other changes. Now, the next layer out, the use cases, those are the application specific things. So maybe you have a website and a mobile app and a desktop app, all that point into the same central accounting system, right? So your central accounting system would be your entities, and all three of your apps could share that. But maybe your Android app and your iOS app and your web app they would each have specific use cases. And those use cases, those application specific use cases, might be different between a mobile and a desktop app. So you would protect those from every other system in the place, but you would not necessarily worry as much about the entities, although you could do bi-directional interfaces to make sure that each layer was also independently testable. But as we see in later chapters, that is also very expensive, and so sometimes it's okay to depend inward, but it's not okay to depend outward. And so again, we talk about the dependency injection or dependency inversion, or the dependency rule, where source code dependencies must only point inwards towards the higher level policies. So in towards the center of the circle is higher level. Nothing on the inner ring can know about the outer ring. Use cases, I think we've covered that. Interface adapters. So this sort of third layer here, that layer there is about passing information from things like your database, things like your UI, things like your web, things like individual devices into the use cases and entities, because you need that sort of buffer for things to go back and forth. But again, by adding that layer, you allow yourself to not be specifically tied to any individual database. For example, you could swap out Cassandra for Mongo, for SQL Server, for Postgres, maybe not with no effort, but your really critical stuff is protected, right? Because recall that storing the data is one part of the problem that we have, but the more important part is, if we're in an accounting system, calculating interest. You want to make sure that the interest calculation is correct. And you want to know that if I pass the correct numbers into that interest calculation, I get the right dollar value back. And it's irrelevant what database you're using, as long as the database has the correct number. And so that's how we are protecting the business, by adding these layers to the system, and such. It does raise a question, because as with Mike here, it's interesting to think about, because we spent 10 years, he spent longer than me, but I've spent 10 years with him making websites for marketing companies, where there is this question of, actually, we just want to crank it out and get the page live. To what level do we actually worry about architecture in that sort of client-driven system? And it really takes a different way of looking at the world, and the job of architecture is around making judgment calls for dealing with the difference between, these are long-term projects, these are short-term projects, these are projects that we have to build within the budget that we have. And so, we cut corners over there and we build for long-term over here. And there are different philosophies and working modalities that we deal with in this stuff. And finally, the frameworks and drivers, which is that outer ring of how we connect to the individual databases. When we move from one, it sucks your soul constantly taking. It does, and I am, I'm not going to denigrate Click because I spent 10 years there, but I am glad to be working in a different way where I can focus on doing really good work for with law. It's like in the financial world, in stocks and stuff, companies are all driven by these quarterly systems, right? Where you have to show profit at the end of the quarter. And wouldn't it be lovely to be able to say, no, I want to have a 5-year plan. I want to do what's best for the business and for the law for the, we live with this product, we own this product, we keep working on improving this one product rather than, you know, crank it out and be done with it. And so anyways, I shouldn't pry too much if you actually are still there. Are you on the product side now? What are you doing? It's been such a while since I've had a chance to chat. Speaking of, who just reached out is Jeff. Jeff Z has reached out, and we're gonna try and grab a coffee in the week to catch up. So there's another name from the past, and I'm hoping he's doing well. I'm looking forward to seeing him. Anyways, so the concept of moving from any ring, going either direction, going outwards or inwards, is called crossing a boundary, because these are the lines that we're working on, right? And so we've said this once already, no name of a variable on the outer ring should be known by a variable on the inner ring. Is that sensei for a bit? You've started your own company in the crypto? Crypto? Are you doing cryptocurrencies? Or are you doing like security crypto? You know what? We have a building an NFT minting platform. Ooh, that's cool. We should talk more, but also I should send you an introduction to a friend of mine who was working on building a crypto mining rig system out in a farm, and I think the two of you would really connect. And I'd send me some links on that, send me some Facebook messages about what you've got so far. I would love to hear more. That sounds really cool. And it's definitely a gold rush right now. Yeah, no, we should absolutely. That sounds so cool. And so, yeah, so when we pass data, it should always be in the form that's most convenient for the inner circle. And we'll talk about what the inner circle is in a second, and that'll make more sense in a second as well. But the conclusion of... Oh, and don't worry about derailing too much, because I'm well over halfway done, and it's only 8:30, and so, this is only going to be a 1-hour show. So, and it's more fun when people stop by anyways. Maybe not for John, who's just listening in to us chatting about like a couple of old hens sitting on a porch, but I think he'd be interested in your NFT platform as well. He's into some cool stuff. But he does the other kind of crypto. He does the security kind. Anyway, so by separating our architecture into layers and using that dependency inversion principle, we design a system that is intrinsically testable. And when the external parts become obsolete, so again, like I was talking about, swapping out databases and things, you can replace them with a minimum of fuss. And so if you had, for example, you were using jQuery on your front end, and you said, I want to rewrite my jQuery to be the latest framework, and so you start writing it in mithril.js, and by the end of the first day, there's AngularJS, so you're like, oh, I want to rewrite it in AngularJS right now. Then by the end of the second day, Angular's out of date, so you start working in Vue, and by the end of the third day, you go, well, React is the thing. Um, and that's a bit of a joke about JavaScript frameworks, but the point is that you can swap out layers if things are highly separated without losing. The point is jQuery. We should all just go back to jQuery. That's it. It's over. It's all been decided. Back to jQuery. Um, so so the next thing we want to talk about in terms of all of that stuff. So we've established that we want to organize our things in layers. We want to have separation between the zones, and we've been talking about that for about 9 weeks already so far. We want to talk now. I'll actually go back to my desktop here. We want to talk about these presenters and humble objects. The humble objects are intended to be the innermost layer. Okay, so that's to say that the data inside your central layer is not it's not tied to any framework. It's not necessarily got an ORM with it. It's really just, I mean, they would be objects, but the values and data within them would take unformatted raw data. It's not taking in JSON. It's not taking in XML. It's not taking in anything that's already wrapped in HTML tags. It just takes the raw primitives like basic strings, basic integers, basic floats, whatever, basic objects, or maybe medium complexity objects. But the humble object pattern is such that it doesn't matter what language that that you're communicating with this central layer in. It takes in raw data and it spits out raw data. There's no HTML wrapping it up. There's no JSON, XML wrapping it up. And so by having these humble objects, and I should state that this is also related to the view model thing, because it is not just the innermost layer. You would also do this with view models to split the calculation of things. Doing your interest calculation can happen in one of two places in a typical web system, for example. So you've got your object, the data comes in, and if you do your calculation on the front end, well, your view or the visual space is, well, it's going to be problematic because you can't test that, right? So you've got your HTML with a front end thing, and how do you load that HTML? If you're going to test HTML as rendered on the screen, you've got to fire up like Selenium with your Phantom JS or your Phantom browser or your headless Chrome, and that slows everything down, right? Because we're talking, it takes 5 seconds to load the page, execute talk to you later, Mike. Tell me more about this NFT platform. I've got a lot of friends who would be interested in that. It sounds really cool. And thanks for stopping by. So it's really hard to test front-end views, though, right? So that's one of the things that we have to find a solution for. And by breaking off all of the data into these things, these humble objects, and passing in only fully calculated, fully baked data into the view, well, so now all of a sudden our view only has to display the exact data that we give it, right? And we can automate the testing of the other side of things, where the automated testing, let me go back to Solo. So the automated testing, we can load up that humble object. We can say, if we pass in these data shapes, we get out these answers, and we can verify that our code works in an automated way. And that's where we can build these systems scalably over time, and with no logic or calculation happening in the front end itself, we make our systems more testable, and that's one of the goals that we're looking for. So the next section that we talk about is database gateways, and gateways contain all the methods to create, read, update, or delete. That's the CRUD operations for our databases. We do not allow SQL statements to occur within our use cases layer. So I'll go back to our diagram here. So this one's, we do not allow SQL to appear in our use case layer. So no SQL, not no SQL, because that's a structured query language statements are not permitted within the use cases layer. They're not permitted within the entities layer, right? They would happen in the gateways. So a gateway would have our select statement. It would have our update statement. It would have our read and our delete, right? And the gateway sends that message to whatever type of database we're connecting it to. But the gateway also, after it has that stuff, it translates it here before it passes it further in. It translates it from this stuff about select and whatever into these inner layers. And that over time allows, that's the goal that we're looking for, where it allows our system to be swappable in terms of that database layer. And in a unit testing situation, it also allows us to use an interface to stub out the calls to the database to something that so we make a fake object that has a create method on it, and we say, if we call this fake object and it returns this, does our program in the center layer still function properly? And so what all of that gives us by using database gateways, rather than having SQL statements on our inner circles, on our use cases and our entities layer, we move that further out. That means we can actually write unit tests for our central code layer without having to connect to a database. And if you think about that, the stub, so we load up this stub database into memory, right? And we all know that memory, the random access memory of our system, is blazing fast. So we load these things that sit in memory, and they give us our faked out create, update, delete, and the responses we get from those function calls is sub-millisecond. It's like nanoseconds, right? But if we can only write tests while connected to a live database, we can only test our system if we're already running SQL Server or MySQL on the back end. Well, suddenly that call has to go from, and sometimes it might even be a networked SQL server. Like, think about that. Think about a networked MySQL, because maybe your web developers don't want to set up MySQL locally, but they still want to run the testing, or we don't test at all. But each test goes from happening in a nanosecond, in this little object sitting in RAM, to it goes out to the network. Now we're talking, maybe now it takes a second to go in, it goes into the database, runs for half a second. Maybe it's a complex query that you're running the test against, and so maybe it takes a whole second and it comes back. Now, if you're talking about a system with hundreds of tests, 3 seconds a test is a much more heavy load than nanoseconds a test. So 1,000 tests that take you a second versus 1,000 tests that take you 3,000 seconds. Well, you can do the math. Your launch time from pressing go to getting into production goes from being a 1 second operation to run all of these tests. You say, yep, it's good, to you hit the button, you wait half an hour, you go get a coffee, you come back, and maybe it's just about wrapping up by the time you've had lunch as well. And that necessarily reduces a developer's ability to keep an eye on the tests, right? So if you think about it, if you have tests that run in nanoseconds, right? You can do 1,000 tests in a second. And, well, your developers on your team can run the entire test suite every time they hit save, right? Which is a big deal. Because as soon as the change that they made, it's like when you're running Webpack Watch or Gulp Watch or something, right? Every time you save your CSS, the page reloads and the change has happened and you can see it right away. But this is with testing the back end. You make your change, all of the tests run within a couple of seconds, and instantly. You get that instant tight feedback loop. And then the alternative is, most of the time, if your tests take 15 minutes to an hour to run all of them, your developer team is not even gonna run them before they check in their code. They're just gonna check it in. They're gonna let the continuous integration system on the server do it, and they're gonna go get a coffee. They're gonna come back and they're gonna, oh, I missed a comma, or I forgot something. You forget something. It happens. So being able to write your tests in a way that ignores the database, that ignores all external systems, that respects these ideas of architectural boundaries, will not just increase the testability of the system in the way that you write your tests. It'll increase the testability in the system in the speed of the tests, which means you're more likely to run them more. So that's the extent of the week. It was so cool to have friends stop by. John, good to see you too. Mike, I know you've already taken off, but it was fantastic of you to stop by. Can't wait to hear about this NFT thing you have going on. And somebody else showed up, but I'm not going to call out anybody who's not speaking up, because you're allowed to remain anonymous. But anyways, thank you so much. That's the end of the week, and we will talk to you again soon, I hope. Next week, I could tell you what's up next week. This was a good one. So next week, partial boundaries, layers. Oh, this is a good week. Well, it's already too late. Next week we'll finish this. We'll finish this up. I really liked this partial boundaries one. So I bought this Corsair keyboard, super expensive. The N key misses all the time. That's supposed to say boundaries. Also, I'm supposed to spell it right. But anyways, never mind. Next week's a really good week, and we are approaching the end, and we've already decided that next book is going to be Accelerate. And thank you for stopping by, and we will talk